we would start with functions. Now, today would be more of getting to know the basics of functions, though you have covered a bit of it in grade 11, but I'm not sure how much you have covered. So in grade 12, it's very less on this part. Okay, so we would be doing a recap a little bit on functions to understand what they are. And in terms of functions, we would be learning what is known as a 1-1 function. 1-1 function, also called as injective function. Okay, first get to know what all we will be learning. 1-1. Then we will learn something known as an onto function. An onto function is known as a surjective function. Now, children get confused on these names. Okay, so slowly you have to develop it. 1-1 is known as injective, onto is known as surjective. Then we will read about another function which is a combination of both. We call it 1-1 and onto, right? 1-1 and onto. And since it is a combination of two functions, so we call this as a bijective function. Okay. Now, if you try to memorize anything in this chapter, nothing will get into your head. You have to understand the basic. This is again argument mathematics. You won't be solving some question to find an answer, like, you know, so blah blah plus so and so plus will give you some answer. It won't be like that. It's argument. It's all on the basis of how much you can argue your case and prove your case. So there will be assumptions, contradictions. So it will be a little bit of language. And when we do language mathematics, you need not tailgate your textbook. It's not about copying line by line of your textbook. It's like fighting your case in a court. As long as your justification is correct and you're not goofing up the grammar so much that somebody is making a wrong interpretation of what you try to say, you are correct. It is not about, you know, exactly going word by word. Why I say that? Because continuity, differentiation, all these chapters will be on this basis. It's a big shift in your mentality when you come to grade 11 and 12 from grade 10, because you won't be solving direct numbers type questions. Okay, so this is what we are going to study, and bijective understanding is very important for our next chapter, which will be inverse trigonometric function. So our focus first will be to understand functions. In order to understand, function is like the grandchild. We first again go back to what we had studied called the Cartesian product. Okay, 1 minute. Okay, we go back to Cartesian product. Ananya, if you have any issue, you are not understanding something and you believe that that's a very stupid question, still ask that question. We are only 2-3 of us, so being stupid in front of 2-3 is nothing rather than being stupid in front of a big crowd. So you can just spell out your query that this is something I'm not understanding. If we can solve it, is fine. So Cartesian product is about two sets A cross B, right? And A is a set which has all elements which we represent with small a. B is a set which has elements which is represented by B. So the Cartesian product will be actually all these A1, means all the sets of its Cartesian product is the set of all ordered pairs AB, where we say A belongs to A and B belongs to B. Means if you have a set like this, which is 1, 2, 3, and you have a set out here which is say 4, 5, 6, so your Cartesian product will be map 1, 1, 4, then 1, 5, 1, 6. Similarly, you can have 2, 4, you can have 2, 5, 2, 6, and then 3, 4, 3, 5, and 3, 6. And we had discussed that if you have number of elements which are P number of elements out here, Q number of elements out here, the total number of elements that we get in a Cartesian product is P into Q, which is PQ. So we have 3 out here, 3, 3, 3 makes it 9, so you get 9. Cartesian product is all possibilities, and when you see them, these are called ordered pairs. In ordered pair, AB is an ordered pair, BA is a different ordered pair. So here we say the ordered pair AB, where the first one comes from A and the second one comes from B. This is what we have learned in grade 11. After Cartesian product, we step into what is known as relations. Relations. So we say relation is the relation R defined from A to B. And what will be A to B? A to B will give you some AB ordered pairs, AB, where we say AB belongs to R. Now we need to understand this mathematically. So here all ordered pairs were involved. Here we will take ordered pairs which belong to this R. And what is R? R is a relation. It's a relation where we can say, for example, A is the set of letters, B is the set of names. Our relation is such that you take A, B, such that all B names start with the letter A. There has to be a relation. So in mathematics, we say relations will be a subset. Okay. Cartesian product is all combinations possible. Relations is few of these. Few of these. Which few? Those few which obey this particular relation R. And we did problems about this. We say A, B, where B is say greater than so and so. Some criteria which this or see here the ordered pair need not follow any criteria. They have only one criteria. This should come from A, this should come from B. That's all. Here it says you come from A and B. You come from A and B. This also has to be satisfied. Along with that, you should also satisfy that when you come along both together, you should satisfy a relation. And the type of relations we studied were three types of relations: reflexive, symmetric, transitive. And a relation which is all three, we used to call them an equivalence relation. Okay. Today we get into, so this was grandfather, father. Today we get to the child, which is function. Function, or written as FN. Functions will be again special class of relations. So what do we get from here? All functions are relations. All functions are a subset of Cartesian product. Every relation will not be a function. That is what we will see now. Every Cartesian product's ordered pair need not belong to the relation. Is this much basic understood? That right? So our idea would be to get into functions. So let's talk a bit on functions. Functions in a layman's language, we will say them as special relations. And when you use the word special relations, you're using an adjective out here called special. Means you are not considering all the relations, you are considering only few specific relations. That means a function itself becomes a subset of relation. So from this particular thing, we get to know that all relations need not be functions. However, all functions will definitely be relations. This is clear? Now let's see in layman's language. Okay. Let's say I have a set A and I have a set B. Okay. Set A, I have got the alphabet, say A, B, and say I've got an alphabet R. And out here I have got some names. Amit. So Ananya is there. So let's take her name also. R. We say Rohit is one name. And then S, we say Sam is one name. Okay. Now we define a relation. We say R is a relation which maps from set A to B, and it gives me ordered pairs A, B, such that B is a name that starts with A, where A belongs to the set A and B belongs to the set B. Very nicely written. So hunt ordered pairs where B is a name, this is also a B, this is also a B, this is also a B. Hunt those names which start with the letters that are there in A. So what type of mapping can I see here? I would say A gives me a Amit, A gives me Ananya, R gives me Rohit. This is what I found. Right? This is relation. Okay, this is relation what we have understood. When you actually come to functions, the difference that you will say, now let's see how functions differ from relations. Okay, if you see how functions differ from relation, then we say a relation R is said to be a function. Okay, a relation R is said to be a function if an ordered pair AB belongs to the function. Number one, don't get confused that he is writing something. Just listen to it. A relation R will be a function if the ordered pair AB of the relation belongs to the function and the function value of the pre-image is equal to the image. Okay, image for every A belonging to the set A and B belonging to the set B. Now we should to understand it nicely. What are we trying to mean by this? Now we say that you can be a function only when the ordered pair satisfies the function. In earlier thing we said this satisfies the relation. I'm going to say that this satisfies the function. So our first thing comes is, what is a function? What is a function? A function is a mathematical operation. A function is a mathematical operation. What type of operation? I will have something called a function, something like, as I say always, it's like a magic box, and I'll play with two variables. The first variable will be known as my input variable, usually my x, and it will give me an output which is a y variable. This is known as our independent variable, and this is known as our dependent variable, because y's value depends on the value of x. Let's say this particular function is a simple algebraic function which is a 2x function, which means it's like a magic box. You enter 1 from this side, it will puke out 2. You give 2 from this side, it's going to puke out 4, right? So I have to pick up an ordered pair. Now what is an ordered pair? My ordered pair is 1, 2 from here. This ordered pair must belong to the function. Yes, it belongs to the function, such that we say the function value of 1 is equal to 2. Okay, this is known as my pre-image, and this is known as my image. In other language, we also call this as our range, and this will be forming a part of domain. This will be forming a part, not one, the entire, all possible things. We'll come to that. Okay, so the function value of 1, this is what we are trying to say. AB belongs to the function. Does 1, 2 belong to this function? Yes. Such that f of A is equal to B. The function value of A is equal to B, where A belongs to A. Yes, 1 belongs to this particular set A and B belongs to the set B. And the function is f of x is equal to y. That's how we write function. Take the value of input, the function value of the input. Now we can have different type of functions, like you can have a trigonometric function like a sin x function. You can have a logarithmic function like a log x function. You can have an exponential function. You can have a power function. You can have an algebraic function, as you want. अब बात आते हैं, what is the difference in terms of function and relation in diagram manner? This will slowly get eased up. Don't worry. Don't break your head so much. What is the exact difference? In a relation, as we said, now let's say this is a set A and set B, and suppose this is a relation mapping. In a relation, you can have inputs. Okay. Graphically, the easiest way to understand, in relation, one particular input may have two outputs, like we saw in the previous example. A gave me a name blah blah and another name blah blah. That's possible. But if this is a function, then this is not true. In a function, if the mapping is a function and this is a A and a B, every input has to have a unique output. Every input has to have a unique output. Are you getting me? Means this sort of mapping is not possible. However, this mapping is possible. This is possible. But you cannot have this mapping. Let's see, for example, let's take a function which is a sin x function. Now ask for yourself. Okay, what is x? X is known as the input. Our input, this is our x, which is input, and this is our output. What are x? X is basically angle measure, and this is values. Okay, so let's take some values. Go to grade 10, 0 degree, 30 degree, 45 degree, and say 60 degree. And you are mapping a function which is a sin x function. Now think yourself. A sine 30 is a half. A sine 30 is a half. Did you get it? A sine 30 cannot be another value. Not possible. Not possible. However, a sine 0 is a 0. A sine of 180 degree is also a 0. This mapping is possible. So many children, when they get confused, they remember it like this. Sir, in relation, this is possible. In function, this is never possible. Never it is possible. But in function, this is definitely possible. This is possible. If at this level you are able to understand this much also, it's fine. A sine 30 cannot have two values, children. But half can be the values of two angles whose sine gives you half. That is possible. So here we said A maps to Amit, A maps to Ananya. Relation wise it is possible, but because we cannot write it like this, we have to give this relation. Our relation, okay, what was our function? Suppose this was a function. In our function we say f of the input should be equal to the output. Our function was a name function. So I am writing f of A is equal to Amit. I am also writing f of A is equal to Ananya. How is this possible? This is not possible. Are we fine? This is not a function. No. This particular is a relation. It is not a function. This is a function. You can ask me, is this a relation? Yes. All functions are a relation. See, the granddad was actually Cartesian product, which was everything possible. Then came the father. The father was relation. Then came the son, which is functions. Functions are very, very specific. Every function is a relation. Every relation is ordered pair belongs to the Cartesian product. But all Cartesian product ordered pair does not give you relation. All relations don't give you function. Let's see one more example. Okay, the more examples you see, the more the clarity will develop. Let's see one more example. Let's say in junior classes we keep on writing f of x, okay, is equal to say root x. This is a function we are seeing. So you ask yourself, let's put some input and let's see some output. Children, this f of x is also known as y. F of x is also known as y. So if you want to see it graphically, we write it this way. This is your x and this axis is always f of x. What in childhood you have known this as x and you write this as y, the same thing. This will give you x for all inputs, the outputs, okay? Now let's look at this function. This function is actually can be written as y equal to root x, right? In my input, what is the input? The input are all the x, the outputs are all the y's. My input is 9. What is the function? The magic is supposed to be root. So the function is supposed to call out the root of 9. It should puke what? It should puke plus 3 and minus 3. Right? Now you try to see it in your under drawing or your eggs. So you have something called 9. You have said that I have a function f of x equal to root x. But 9 is mapping to plus 3. 9 is also mapping to minus 3. Go back to your diagram. This is not possible. So what you used to write in say 10th grade and all, that f of x equal to root x, now we are better mathematicians, we will say, boy, this is not a function. This cannot be a function. A function cannot map in two values. Is this getting clear? However, if we restrict ourselves, okay, if you restrict yourself and you say f of x in such a manner that you're considering the y's such that the y's are only positives, then definitely it will be a function. See, when in junior books of grade 8, 9, 10, when they teach you something called root of x, what they actually mean you is all positive outputs. In this case, definitely it will be a function. Just see, root 9 will puke a value. I entered 9 from my input. Function is root 9. Then it will only puke plus 3. Now it's a function. Therefore, whenever you write something as want to quantify a relation as function, you have to be very, very specific that is the definition of function being met. Means one input, one unique output. Two inputs may have the same output, but one input cannot have two different outputs, because then you won't be able to say, you can't say this is possible in function. F of x1 gives you y, very much possible. F of x2 gives you y, very much possible. Sir, I'm getting confused. No issues. Just see, sine of 0 is equal to 0. Sine of 180 is equal to 0. This is possible. What is not possible is f of x, once you say I get y1, second time you say f of x is equal to y2. This is not possible. Sine of 30 cannot be 0 once and sine of 30 cannot be half once. That's not possible. Has something entered? If it is little bit, also fine. And it took me many years to understand all these things. How can you understand in one go? These are all easy to learn and easy to forget. Some more checks. How we can understand as a function, say graphically. Okay, let's see graphically. Okay, now let's draw some cute diagrams. Why this way? Okay. One minute. The only problem with this software, it doesn't retain the previous signal. Okay. Okay, fine. Let's see some three mappings. It will become clear to you. Okay. Let's say this is my x and these are y's which are represented by f of x. Similarly, this is a x, this is a f of x. This is a x, this is a f of x. Okay, right? Fine. Now say suppose I have a mapping came out something like this. Or let's go by our sine curve. Our sine curve will give a mapping like this. This is your sine curve. Okay, that's fine. Now we want to check whether this plot is representing a function or not, whether this represents a function or not. The best way to check that is what we call is a vertical line test. A vertical line test will always tell you whether your particular plot is a function or not. Draw a vertical line anywhere, okay? We are trying to say, let me draw a vertical line. Let's say I draw a vertical line out here, okay? And I'm trying to say that this is some function y equal to f of x. Some function, this can be trigonometric, logarithmic, whatever it is. I'm checking whether this is a function or not. So I did a vertical line test. So after doing this vertical line test, I get two things. I get this point out here. So what is this point? Okay, I get a point out here and let me map this point. This point is such that you might not be able to see the dotted lines. Okay, hang on. So, okay. So this is some value and similarly, this is some value. Okay, this is some dotted line. So I write like this. I call it a value x1, and for this x1, the function value is fx1, right? And now tell me, for this particular input, do you get any other point on the yellow curve? No. That means this is a function. This is a function, because for our function, for every input, we should get one output. Okay, right? Fine. Let me draw one more horizontal line. Vertical line. Let me draw one vertical line out here. Fine. So this is a point. This is a point, say x2. Then this point is fx2. For this particular point, For this particular point, if you have this as the input, then you have only one unique output. This is a function. However, let me make a curve like this. Suppose I have a spiral curve. Now I try to make a vertical line test out here. See, I make a vertical line test. Wow. I'm intersecting 3 points. Now see, for x1 as an input, you are getting a fx1 out here. You have a fx2 output. Let's say this is fx3. You're getting 3 different output for the same input. Means this mapping is like this. If you see it in the egg diagram, it is something like this. For a single x1, you are getting 1, 2, 3 different. This is not a function. Is function definition now getting a little bit clear? And in function, we say that when you map from A to B, right? Let's understand a little bit more. Let's say this is your input set A and the output set B, right? We don't call the B set as output. We say that, and there is suppose a function. Now this function will take only, this is like a magic pot. It won't take every garbage. Everything that is permissible as an input as per this function. For example, I am doing a sine function where it is sine 30. So everything should be a degree measure. I cannot write sine of Ananya. That's not possible. So every input which is defined by this function, right? Those inputs, the valid inputs, will be known as your domain. So what is domain of a function? Domain of a function are all possible inputs. All possible inputs. That is known as the function. Okay, try to understand. The function is trying to map a relation from A to B. So A is known as my domain. All possible input. What is B? Now in B, I can have various elements in B. However, I find that there are only few lucky elements which find a mapping. There are only few lucky elements which find a mapping. Those lucky elements will constitute what is known as range. So what is range? Range is the set of elements which are the output for every possible input. For every possible input, you get some outputs. Those will be known as range. Have you understood? Let's say this is the range. Say this was the real number set and you are trying to test it for root 9, root 25. So there might be something called a number 2. The number 2 does not qualify. In that case, the complete set, that is the ones which get mapped as well as the ones which do not get mapped, that will be known as my codomain. Codomain is like the big refrigerator from which you pick only few, which is known as your range. How did the range come out? The range came out based on the domain that you selected. Domain is frozen. For every possible input, there will be. Now your next question will be, sir, can I eat up the whole this set? Yes, possible. In that we will say the range and codomain of the set of the function is same. The range is equal to the codomain. Sir, is it possible that out of this only one finds a mapping? Yes, why not? Yes. But there has to be a mapping. Is this much clear? Okay. So, how do we define a function? Now I'm coming back. A relation. Now just revisit this definition. We'll write once again, no issues. A relation R mapped from a set A to B is called a function. Is called a function. So you're being very specific. A relation mapped from a set A to B. So let's make a set A and let's make a set B. This is a set A, this is a set B, and you're mapping a relation. And you are calling this a function F. So I'm naming this as a function F. F. If an ordered pair AB belongs to the function, what is the ordered pair? This is always known as the pre-image, and this is known as the image. This pre-image will always belong to the domain. The image will always belong to the range as well as codomain. First of all, whatever means, if I was considering root 9 for all positive value, then this is 9 and this is 3. This is 9 and this is 3. Root is the function. Root is the function. This is 9, this is 3. Does 9, 3 belong to this relation mapping? Yes. So it should belong to the function, which is the relation. And f of a, the function value of 9, should be 3 for every a belonging to a. This is known as for every. This is for every. And for every b belonging to b. Now see, this is how we write in mathematics. Pick up two sets A and B. In these A and B, there will be small elements, small a, small b. Form an ordered pair AB. This should belong to this function mapping and it should be satisfy the criteria that f of A is equal to B. So let me give an example out here. Let's say if this was my angles, and if this is a set of real number R, if this is a set of real number R, okay, and I have something called 0 degree, 30 degree, I have 180 degree, okay, I have values like 0, I have half, I have root 3 by 2, I have 0, these are my values, right? And I pick up an ordered pair from here, I pick up an ordered pair 0 degree, 0. Then I ask myself, does this belong to this function? You should say, sir, what is the function? Okay, the function is a sine function. Sine. And we would say that, yes, sir, if you take sine of 0, you do get 0. That means this belongs to the sine function. Very good. After that, we should be able to write f of a. So this belongs to the sine function. No issues about that. Criteria number 1 solved. The second thing should be, is sine of 0 degree equal to 0? Yes, it satisfies for every a belonging to a and b belonging to b. So all the a's, if sine 30, then you are picking up another ordered pair. Suppose you are picking up an ordered pair, 30 half is an ordered pair you are taking out. Ask yourself, does 30 half satisfy the sine function? Yes, 30 is present here, half is present here. It satisfies. This ordered pair is possible. Now check if the ordered pair meets the criteria or not. How do you check it? You will check by applying sine 30. Yes, sir, it is satisfying the criteria. Then I would say this is a function. Samjhin? Little bit? Okay, so let's get into our first type of function. Now this was generic. Yeah, nobody's going to ask you in grade 12 about all these things. This you should have been clear from grade 11. But grade 11 is grade 11. Okay. So we now learn about a function which is known as 1-1 function. Very easy. 1-1 function. So by now we know function should have 2 eggs. Yes, sir, there are 2 eggs. Sir, take an egg from x and y. Y are the image eggs, x are the pre-image. 1-1 function is very simple. 1-1 function says only those functions where each input has a unique output, each output has a unique input. Means, now see how nice it is becoming. Okay, listen to me. Function allows you this mapping. Sine 30, sine 120. It allows you this map. Sorry, sine 0, sine 180. Function allows you this mapping. 1-1 is a special category of function which does not allow you this mapping. 1-1 says, look, in 1-1 function, every output should have a unique input only. This is 1-1. Number of elements here will match the number of elements out here. Sir, is this 1 1 function? No, this is not 1 1 function. We still have one element which did not find any marriage out here. This is not 1 1. Are we understanding this? So now children, I know it gets difficult, but you have to now slowly, but we can't draw these eggs every time. We have to think like mathematician and think like a computer programmer. How would you write this? I would say, if a small x is an element belonging to the set capital X, right? Okay, say small x1 is an element belonging to capital X and small x2 belongs to capital X, right? If these two are true, and x1 is not equal to x2, x1 is not equal to x2 means these two are, what do I mean by this? That these two are distinct species. If this is dog, this is cat, then for it to be a 1 1 function, your fx1 also cannot be equal to fx2. Now you need not satisfy function, it is already a function. You are satisfying speciality within a function. Neha, samajh mein aa raha hai to beto? You're satisfying speciality within a function. You say that this is my function, no issues. This is my codomain of my function. Okay, and this is my domain. So from my domain, I picked up a x1, very good. I picked up a 0 degree. I picked up an x2, I picked up a 30 degree. Are they same? No, sir, they are not same. Very good, they are not same. Then their sign values also cannot be same. Means sine 0 and sine 180 both map to 0. But this is a function, but this is not a 1 1 function. 1 1 function ke liye it's simple. If blah blah is tlatla, then these two also have to be different. As simple as that. Right? Okay. Let's now see 1 1 we have seen. Okay. Okay, 1 minute. I'll just pick up an example. It will become more clear. 1 minute. Let's see. Okay. Let's see some in terms of graph. How can we understand whether the function is 1 1 or not? Okay. Take your time to absorb these things. It's a little bit complicated at your level, but we can't help it. Let's see this. I have a function mapping like this. This is a function, children. Y equal to fx. Now you can tell me, sir, how do you know this is a function? Do a vertical line test. For every input, you have one output. For every input, you have one output. Now the question comes, is this 1 1 or not? Means, is this injective or not? 1 1 is also known as injective. Okay. Is this an injective function? Okay. For 1 1, what is the criteria? Everyone should map to only 1. Sir, this side is okay, but this side it should be, everyone should have only one mapping. For this, what we do is known as a horizontal line test. Now see the beauty of the horizontal line. I put up a horizontal line out here, right? And now you yourself will answer. Sorry. Okay, now see the beauty. I have a value x1 and I have a value x2 in my input. In my input from the x, and this is my output y, also known as f of x, y equal to fx this side. Okay. Tell me from the graph, is x1 equal to x2? No, x1 is not equal to x2. Very good. x1 is not equal to x2. Do they belong to x? Yes, they belong to x. But both of them are puking the same value. fx1 is coming equal to fx2. This is not a 1-1 function. Injective नहीं है, function है लेकिन injective नहीं है. For two distinct outputs, you are getting the same input. Sorry, two distinct inputs, you are getting the same output. This is not possible. Let's check it a little bit more from trigonometry. Okay, just look at this graph. This is something that you have learned from your 0 degree. This is what 90 degree sine graph. This is 180. This is 270, and this is 360. Here the value will be how much? +1 as the maximum value, and here the minimum value will be -1. Now we all know this is a sine curve, y equal to sine x. Now our first question comes, sir, is this a function? Yes, this is a function. Draw a vertical line, it satisfies. But sir, is this a 1-1 function? Okay, for 1-1 function, we will make a check out here. Draw a horizontal line. Sir, we drew a horizontal line. The horizontal line has given us two inputs. What are those inputs? Sir, this is an input x1, this is an input x2. Such that you are getting an output y1, and you are saying sine x1 is equal to y1, sine x2 is equal to y1 again. Is this correct? Yes, this is correct. But does this satisfy 1-1 criteria? No, it doesn't satisfy 1-1 criteria. This function will not be called a 1-1 function. Tell me, children, is 1-1 function getting clear now? Right. So we say there are two ways to write in terms of 1-1 function. Okay. Now, how do we write or define a 1-1 function? There are two ways. I say if x1 belongs to a set x and x2 belongs to a set x. Now, this is the straightforward approach definition. It is all, you have to think like a lawyer. This is a straightforward approach. Okay, we'll say, is Neha right now in Hyderabad? The better way to answer is, we searched for Neha in Kerala and found her. So she is not in Hyderabad. That is a counter argument. Another way should be, we went to her house and we found it locked, and on inquiry found that she is right now in Kerala. That is also correct. So we'll define this from both perspectives. Okay, we say for any x1 belonging to x and an x2 belonging to x, if x1 is equal to x2, see children, see, look at the beauty. x1 and x2 both belong to input, and we are saying if they are the same, then the outputs must also be same. Ananya, do you follow Hindi better? Little bit? Okay, so ये हिंदी में ज्यादा मजा आएगा. अगर आपको लगता है कि x1 और x2 दो अलग है, क्या वो इंजेक्टिव फंक्शन बना सकते हैं? अगर उनके आउटपुट भी एक ही तरह दिखते हैं ना, दैट मींस x1 और x2 अलग नहीं थे, वो एक ही था. आपकी आंखों ने दो देखा, लेकिन आपको करेक्शन में मिल गया कि उनका आउटपुट वैल्यू भी सेम है. You thought that there are different inputs, but you found that the different inputs are giving the same output. Different, and they are same. You're saying they are same, then the outputs also should be same. Now let us see the ulta way of defining. If x1, sorry, not equal to, children, belongs to x and x2 belongs to x, and if x1 is not equal to x2, if x1 is not equal to x2, implies fx1 is not equal to fx2, then the function is injective. See the argument. I took two different inputs, and after taking the different inputs, for each input, the function value are different for both the inputs, then yes, it is an injective function. Shall we write it properly now? You can write it. A function from A to B, okay? Both, we will write it in preferred version as well as in the counter-positive version. So we write here, you can write a function from A to B. We'll write it like this, see? A function, and try to take some time to absorb this definition. A function from A to B is said to be injective. In bracket you write 1 1. एक आदमी का एक ही मैपिंग 1 1 or 1 to 1 if for all x1 equal to x2, or say, sorry, we write it like this, if for all x1 and x2, if for now we are going legally, for all x1 and x2 that belong to A, you find fx1 is equal to fx2, implies x1 must be equal to x2. Now try to read this once again. If you have a function from A to B and you say that it is injective only when you pick up two inputs that belong to the domain and you find that their function values are same, then in that case the inputs must be same because you have already said that it is injective. शायद आप अभी भी नहीं समझे हो इस चीज को, सुन लो पहले. ये फंक्शन इंजेक्टिव है, आपने पहले ही assume कर लिया है. You have assumed that it is injective. Have you understood? We assume that this is injective. Okay, let it be humorous now. Let us assume Neha is in Hyderabad. It is stated. We still found Neha in Kerala right now. In that case, our statements, and we say, no, sir, what I said is correct. Neha is in Hyderabad. But I have seen Neha in Kerala. It is possible only if Kerala is Hyderabad. How beautiful, are you getting it? आपने पहले ही बोल दिया है ये फंक्शन इंजेक्टिव है. इसको ध्यान में रख के आपने दो इनपुट्स लिए x1 x2 और इन इनपुट्स के लिए आपको सेम आउटपुट मिल गया. आपने दो इनपुट्स लिए x1 और x2 और इन दोनों इनपुट के लिए आपको कैसे आउटपुट मिल गया? एक ही आउटपुट मिल गया fx1 और यही आउटपुट है fx2. अरे ये तो 1 1 नहीं हो सकता है, पर हमने बोल दिया ना ये 1 1 है. ये तभी पॉसिबल होगा जब ये x2 x1 के बराबर होगा. In that case, this line loses its sanctity and the line comes as like this. This is the legal definition. पहले इसको रट्टू मारने के लिए बड़ा इजी रहता है. We're not getting it. That's why I say if you try to memorize, you'll not understand. If a function is injective and you take two inputs that belong to the domain or the input set and you find that the outputs are same, then if it is injective, the inputs have to be same. Otherwise, ये नहीं हो सकता. This is one way. Now see the counter-positive definition. Okay, the counter-positive definition says a function from A to B is said to be injective. Is said to be injective if x1 not equal to x2. Now see, now we are straight away saying x1 is not equal to x2. Now see the beauty of this definition. We are ourselves saying that Neha is at Hyderabad. Neha is at Hyderabad, right? And we are finding that Neha is in Kerala. Then we have to say what you found at Hyderabad was not Neha. As simple as that. Yes. So we say that the function a to b is said to be injective if x1 not equal to x2. मतलब आपने ऐसे, now in this case you are taking an x1 different and an x2 different, and you are still saying that the function is 1 1. Then an x1 not equal to x2 should imply fx1 should not be equal to fx2. Sir, what did you assume? Sir, I assumed that the function is injective. Correct? Sir, I took two distinct inputs. Correct? You still want to call it injective? Yes, sir. Then please ensure that fx1 and fx2 will be two completely different. These two cannot be equal. Yes, injective. Clear? Actually, if you make that under drawing, it becomes very clear. But when you write these legal statements, it makes it more, your understanding becomes more clear. That if you take two different, see how to see these two definitions. First we said, I took two. I did not call different here. I took two entries or two inputs and I found the output was same. Such thing can be possible if the inputs were same. In the second, I'm saying, I'm taking two different inputs, yet I want it to be an injective function, then the outputs must be different. Clear? एक दिन में हो सकता है, but in one day you will not understand. Okay. Now, let's see some functions. Okay, some examples. Let's see. You guys tell me whether those functions are injective or not. These are all functions. So this is a function which is a phi function. Okay. Now you'll say, sir, phi means null set, none. These are all Greek letters. Phi means this is some function mapping. कुछ तो एक mapping है. And let's see what our mappings are. We have a 1, 2, 3, 4 on this side, and I have a A, B, C, D. Children, this is very arbitrary. Okay, you have to just see the mapping. Just see the mapping. I say 1 is with B. Okay, like taking some examples. 2 is with C, 3 is with A, and 4 is with D. Right? You see this mapping and tell me, is it a 1-1 function? Why is it a 1-1 function? Every input, वो तो होना ही पड़ेगा function के लिए. 1-1 के लिए every output should have a unique input. Input for a unique output तो function होना ही पड़ेगा. इस side से check करो. And is everything mapped? Yes. Yes, everything is mapped. Right. Let's see one more. And tell me on this one, okay? Now this is a Greek letter that we call as chi. CHI. The way we write it is you put a slash like this and you put an alternating symbol. That's chi. So chi is the function which maps from same, say 1, 2, 3, 4, and we got A, B, C, D, and our mappings are this time on this manner. Say 1 is to A, 2 is to B, 3 is to B, 4 is to D. Is this 1-1? But this is a function. This is a function, huh? Function. This is possible. This is not possible. I think 1-1 is clear then. Okay. Some examples also we'll see. Let's see. Okay.